right, so now these two 3's cancel out. So you have 25, x to the 3 minus 1 is just x squared. Plus 10 times 2 is 20. X to the 2 minus 1 is just x. Plus 4 times 1 is just 4. So that's our f prime of x. Okay. So we need to find where f prime of x equals 0. Because remember, that's our horizontal tangent line. Okay, so that means we have to find where, move that up a little bit, 25x squared plus 20x plus 4 is equal to 0. Okay. If you notice, that's a perfect square trinomial. Okay. And it actually falls to the a plus b squared equals a squared plus 2ab plus b squared. Okay. Because if you rewrite this, it's 5x squared plus, we'll leave that blank for now, plus 2 squared. Then that means if we have 5x squared, if this middle term equals 2 times a times b, then all we have to do is plug it into that formula where this is your a and that's your b. Okay, so 2 times 5x is 10x times 2 is 20x, so it equals 20x. So it's a perfect square. So we know this just factors into 5x plus 2 squared, which equals 0. We'll move that up some. Okay. So if we square root both sides, of course, you get the square and the square root cancels out. So you get 5x plus 2 equals 0. Subtract 2 and divide by 5. X equals negative 2/5. Yes.
It would be plus minus because square root is 0.
Oh yeah, plus or minus 0.
Plus minus 0.
Yeah,
and then
it would still be 0.
Oh, it would just be still 0, and then you would just minus 2 like normally, and then you'd be rid of, or would it be plus minus?
Oh no, just 0. Yeah. Because when you square root both sides, you get to plus or minus 0.
Right.
So it will be 0 either way. So if you had negative 2 plus 0 or negative 2 minus 0.
If it was like something else though.
Oh yeah, if you had like 5 on the other side, then it would be plus
then
or
it would
minus.
have to be. Okay.
Yeah. All right. Any other questions on this one? All right. So quick side note. Let me see if anyone's still writing. Oh. Okay. Okay. So if you had a function where if they told you to find the horizontal tangent line and there was no real number for it, then that means there is no horizontal tangent line. That means at no point do you have a slope equal to 0 on that graph. No real solutions. For f prime of x equals 0, then the function f of x has no horizontal tangent lines. Okay, so that can mean it could be constantly increasing or constantly decreasing, but at no point does it level out to where you have a slope of 0. All right, any questions on that one? All right. Okay, so now we're going to find the equation of a tangent line. Okay, so let's say, for example, I want to find an equation of the tangent line to the graph of f of x equals x squared when x equals -2. Okay, so the first thing you're going to do is find your x and f of x, which really is just your x and f of x. It's going to end up being your x1 and your y1. Sorry about that. Okay, so we know our x is equal to -2, which means our f of -2 is going to equal -2 squared, which is 4. Okay, so you get the ordered pair of -2, 4. So remember, that's your x1 and that's your y1. Okay. So next, you're going to find your slope, which is your f prime of x. Okay, so we know if our f of x is x squared, then your f prime of x is going to bring down the 2. So it means your f prime of x is just 2x. Okay. So if we know f prime of x is 2x, when x equals -2, f prime of -2 is equal to 2 times -2, which is just -4. Bring that up some. Okay. So everything we're doing involves just being at -2, or x equals -2. So this is our slope at x equals -2. Okay, so our third step is an oldie but a goodie, and we're going to use the point slope form. It's y minus y1 equals m times x minus x1. Okay, so now we just plug it in. Okay, so you have y minus, remember our y1 is 4, equals your slope, which is -4, times x minus x1, which is -2. Okay, so that gives us y minus 4 equals -4, x plus 2. Y minus 4 equals, once we distribute that, let me kind of clear that up a little bit. Okay, so you have negative 4x minus 8. Add 4 to both sides, you end up with y equals, let me bring that up some, negative 4x minus 4. Okay, so that's your equation of the tangent line. So to give you an idea of what that told us, okay, so let's say that's your x squared. Okay, this is your y-axis, this is your x-axis, and this is the graph of f of x equals x squared. If you go to negative 2, let me make that a little bit smaller. Then right on the graph at that point, if you have your tangent line, remember that tangent line is supposed to barely touch at that point. This is the graph of that tangent line. Okay. So if you were to pick the tangent line at x equals 4, it would have given you a graph over here somewhere. So that would have been completely different. But this is actually the graph of negative 4x minus 4. All right. Any questions on that one?
So the final answer is the y equals negative 4x minus 4?
Yes. Yes. Mm-hmm.
Why did you use y versus x? If we know what x2 is, we're trying to figure out what y is? Or?
Oh no, for this one we're just trying to figure out the equation for the tangent line. Okay, so we know so we can figure out what the slope is, but if we want to figure out an equation for this particular tangent line, we can go through those steps. Okay, so this gives us not just the slope, but the equation to that slope. So it's kind of like if you knew the slope and you say, okay, between this point and this point, you can kind of figure out just the slope.
We have x and we're always going to use y. We have y, we're always going to use x.
Y and x for which part?
For the opposite side, where it says y minus y1.
Oh, you mean for your point slope form? Oh, for this, oh yeah, if you always have at least one point, that's why when they gave you x equals negative 2, you could actually find your y by plugging it in. So now you have your x1 and y1, so the only thing missing was your slope, which was the second step. So basically, I guess you could say the first step was your point, second step was your slope. Then the third step was just plugging them both in to the point slope form. Oh, move that up some. All right. Any questions on that one?
So we find the prime by finding the slope. So when you find the prime equation, then you plug it in to get the slope.
Yep. All right. Oh, you've got enough time. Okay, so now we're going to go over the product rule, where if you multiply two functions, so derivative with respect to x, f of x times g of x is going to equal the first times the derivative of the second. So f of x times g prime of x plus, clean that up some, the second times the derivative of the first. derivative of the first. Okay. Maybe that's how I remember it. Okay, so just like before, we have our proof. Okay, so we know the derivative with respect to x of f of x times g of x is going to equal the limit of f of x plus h times g of x plus h minus f of x times g of x all over h as h approaches 0. Okay. So in the numerator, we're actually going to subtract and add f of x plus h times g of x. Oh, move this over some. So the limit as h approaches 0, f of x plus h times g of x plus h minus f of x plus h g of x plus f of x plus h g of x. So technically we just added 0 since we subtracted and added the same thing. Minus f of x g of x all over h. Okay. Now if you notice in these two, you can factor out f of x plus h. Okay. And you notice in these two, you can factor out g of x. Okay, so you have the limit as h approaches 0, f of x plus h, and we might as well move that completely down to the front. Times g of x minus g of h. X plus h minus g of x. Plus, if we factor out the g of x, bring that down a little bit more. Then we're left with f of x plus h minus f of x all over h. Okay, so since these two are multiplied, we can apply the limit to those two. So the limit of f of x plus h as h approaches 0 times the limit of g of x plus h. Bring that up some. Minus g of x all over h as h approaches 0 plus, so you have those two, might as well block that off, g of x, or the limit of g of x as h approaches 0 times the limit of f of x plus h minus f of x all over h. As h approaches 0. All right. So here, if you actually use direct substitution and plug in your h equals 0, you have the limit of f of x. Well, don't really need the limit of f of x because you plugged it in. Clean that up a little bit. There we go. All right, so this one, direct substitution, we're just left with f of x because h became 0. And this here That's our g prime of x. Let me bring that down just a smidgen so it's not all cramped up in there. So f of x times g prime of x plus, here, direct substitution, if you plug in h equals 0, you're still left with g of x. Times this, remember that's the formula for f prime of x. First times the derivative of the second plus the second times the derivative of the first. So we have our formula. All right, any questions on this one? All right, leave this up for a few seconds.
Are we also doing quotient and shade? I was just wondering today too.
Yep, we should be able to squeeze in the quotient rule.
Okay. How did you know necessarily how to factor out the f of x plus h in each problem, and then the g of x in the separate one?
Because with this one, you knew you wanted to create a f prime of x and a g prime of x.
Right.
So to get the g prime of x, you had to get rid, g of x, well, g prime of x rather, you had to get rid of this f of x plus h.
Yeah.
Okay, so that means you had to, I guess you could say, add a f of x, or subtract it rather, so that you can factor out that f of x plus h. So once you factor out that f of x plus h, now on this side, which meant you needed a g of x plus h because you needed a g prime. So if you had your g of x plus h by itself, and if you can get rid of that g of x, or rather get it by itself, then you can kind of maneuver it. There are different ways, because I know with this one I used to kind of get confused a bit, because I was like, okay, do I add and subtract? You knew you had to add and subtract something. You add and subtract f of x, or do you add and subtract f of x g of x? So this is the one that worked. So if you remember just that part, even though it was taught to me, you still would forget what to subtract and add. But if you can remember to just subtract then add that, you'll be okay.
So you have to subtract f of h and add g of x, is that saying?
Nope, subtract and add it. So here, I just subtracted f of x plus h times g of x, then I added the exact same thing.
Okay, I see.
So this way you're not changing the value, you're just basically adding 0.
Okay, and then after we were able to factor it out because there are different constants and there's the plus and minuses to
Exactly. Yeah,
separate them.
exactly. All right, any other questions? All right, so let's get to an example, or a couple of examples. Okay, so let's say if we wanted to find the derivative of, let's say, h of x is equal to 3x minus 2x squared times 5 plus 4x. Okay. So we're multiplying two different functions. That squared looks a little bit odd. Let me straighten that up. And that clock's going to shut off in about